Unit 4, Lesson 7. Okay, so your skills maintenance is on page 171. Go ahead, attempt that page, and pause the video. Alright, so for skills maintenance today, we were figuring out the operation that we were doing for each of these equations. So in the first one, you got to think 3, what operation are we doing to 4 to get us 12? I see 3 times 4 is 12, so multiplying is the operation. For number 2, okay, 54, what 6 is equal to 9. Okay, adding, subtracting, that's going to get us nowhere close to 9. So we got to think multiplying or dividing. And if we're going from a bigger number to a smaller number, we are doing division. 54 divided by 6 is equal to 9. All right, 8, what 6 is equal to 14. 8 plus 6 is 14. 41, what 37 is equal to 4. This one is subtracting. 41 minus 37 is 4. Okay, and the next one, 20, what 4 is equal to 5. 20 divided by 4 is equal to 5. Number 6, 3 plus 4 is equal to 7. And then finally, number 7, 41 plus 37 is 78. And then finally, 8, 20 minus 4 is equal to 16. Okay, so again, figuring out that operation that needs to go in between the two values to get your number. All right, so today I will describe how the input in a table changes to the output in a table using word and algebraic expressions. I will write an equation to relate the input to the output. So when we have these, okay, you have your input, okay, and then you're going to change it in some way, and that's going to be your operation to get us our output. Okay, so we're going to have a table like this. Okay, you got an input of 15, you get an output of 5. Okay, and then if same operation now, you have an input of 20, you're going to get 10, 12 to 2, and finally 28 to 18. So it's all a matter of figuring out that pattern. What operation are we doing to get from that input to the output? So steps in order to do that. Find out what is going on in the pattern. Okay, so in the first one, we're going from 15 to 5. So we got to think of ways we can get from 15 to 5. So in the one they're doing, they're thinking division. 15 divided by 3 is equal to 5. Now, it works for that one, so we got to make sure it works for the other ones as well, for the 20, 10, 12, 2, 28, 18. Okay, so if we try with 20, we said divide by 3, 20 divided by 3, that does not equal 10, so therefore we got to try a different type of pattern. Okay, so I would say 15 to 5, so if we did division, okay, we're going from a bigger number to a smaller number, you're either using division or subtracting. Okay, so 15 minus 10, that is equal to 5. So let's check to see if that pattern, okay, or that operation works with the other inputs and outputs. 20 minus 10, that is 10. 12 minus 10, that is 2. 28 minus 10 is 18. So that is our pattern. Okay, we are subtracting 10 from the input to get our output. Okay, so the next thing is to create an algebraic equation. Okay, so your inputs, think of it this way, that's our input, that is changing always. Okay, and when we are talking about an input-output table, okay, input is always X and output is always Y. Okay, so here's your Y. Now the thing that does not change out of the whole thing is that minus 10. Okay, so your blue and your green, those are varying. Okay, so, and we said the blue is your X. Okay, which is your input. The Y was your output. So when we were writing this, the output, which we did with green, that was always equal to the input minus that 10. And again, we said input was X, output was Y. So what we got here, Y is equal to X minus 10. Your output is equal to the input minus 10. So that is our equation. Y equals X minus 10. All right, so another one. Again, finding that pattern from the input to the output. Sometimes it's a little easier to not just start with that first one. Okay, to get from 1 to 1/2. That's kind of tough. Okay, so let's look at 4 to 2. How am I going to get from 4 to 2? You can either subtract 2 or you can divide by 2. Okay, so let's check to see which one of those works. Okay, so in this case, we said 4 minus 2 is equal to 2. 16 minus 2 is not equal to 8. So minus 2 is not the operation. So the other operation we said was to divide by 2. 4 divided by 2 is 2. 16 divided by 2 is 8. Okay, so it's looking like dividing by 2 is our option. 1 divided by 2 is equal to 1/2. And then 5 divided by 2 is 2.5. So in this case, our pattern is to divide the input by 2 to get the output. So now remember, input is x, output is y. So we always did the input divided by 2 is equal to the output. So that is our algebraic equation. Okay. So apply skills, go ahead, page 172, 173, give it a try and pause this video. So again now, starting with our apply skills here, okay, we need to figure out the pattern. Okay, we're going from the input is a bigger number to a smaller number. So our options are either to subtract or divide. If I subtracted, we would have to minus 40. If I was to divide, I would have to divide by 9. Okay, 45 minus 40 is 5. 45 divided by 9 is 5. Now, let's check to see which one works in the other input outputs. 36 minus 40 is not equal to positive 4. 36 divided by 9 is equal to 4. Okay, therefore, our pattern is going to be that divide by 9. 1 divided by 9 is 1/9. 9 divided by 9 is 1. So dividing by 9 is our pattern. Okay, so to describe the pattern in words, we are doing the input divided by 9 equals the output. Okay, now it's asking for an algebraic expression and an algebraic equation. Remember, the expression, there is no equal sign. So in this case, okay, we took the input, which is represented with x, and we divided by 9. Now to make it an algebraic equation, you are just saying the output is equal to that expression. Okay, so y is equal to x divided by 9, where y is your output, x is your input. Alright, so on the next one, you got to find that pattern again. Okay, we can either add 50 plus 50 is 100. 50 times 2 is 100. We got to figure out which of those work with the other ones as well. Okay, 75 plus 50, that works. 75 times 2, which is 150, does not work. So our pattern is the input plus 50 equals the output. And that's what we're going to write to describe the pattern in words. Input plus 50 equals the output. Okay, so then our expression, you're taking again x, which is our input, and you're adding 50. That's your expression. There's no equal sign. For an equation, we will have an equal sign, and the output is equal to that expression again. Y is equal to x plus 50. Again, output is y, your input is x. All right, so we're going to solve percent decrease problems now in our problem solving. So what we're going to have is we're going to have a table. Okay, we're going to decide which vehicle has the greatest percent decrease, and we're going to show all of our work. So if you remember, it's always going to be the change over the original is equal to the percent over 100. Okay, so in this case, we're going to do the Ford Explorer in blue. Okay, so we need to figure out the change in price. So if the original price is $15,000 and went to $12,000, you're going to do $15,000 minus $12,000, or just think 15 times minus 12. We get a change of $3,000. Okay, so that is the change in terms of dollars. So 3,000. Well, let's do this over here. We'll do the Ford. We had a change of $3,000. Okay, with an original price of $15,000, and we're going to set that to the percent over 100. We don't know the percent. That's what we're trying to figure out. Over 100. Oh, not 1,000. 100. So now at this point, we have to solve for this proportion. Okay, what's going to be a little easier is if we simplify the left side of that proportion. Okay, we got a 0 over 0, 0 over 0, 0 over 0. So we can think of that as 3/15 is equal to x over 100. Okay, now using our vertical strategy, okay, to get from 15, I know 3 times 5 is 15, so 15 divided by 5 is 3. So we got x is equal to 100 divided by 5, which is equal to 20. So we had a 20% decrease for the Ford. All right, so let's go ahead, let's do the Chevy. We go from 18,000 to 13,500. So 18,000 minus that 13,500, which is going to equal 4,500. That is our change. Okay, so we got the Chevy. She said was a change of 4,500. Okay, over that 18,000, which is the original price. We're going to set it to x over 100. Again, eliminate those zeros that we can. Then from there, we need to solve. Okay, now actually simplifying here is probably going to make it harder. Okay, I'm going to use my horizontal. Okay, and we're going to think 18,000 to get to 100. Okay, I know 100 times 18 is 1800. Okay, so 100 times 180 will be 180 or 18,000. So what we're going to do is we're going to divide by 180. Okay, 4,500 divided by 180. I'm not going to go that route either. Let's try this one more time. Okay, let's go ahead. Let's do that simplifying. We're thinking 45 to 180. And we're going vertical. Okay, so 45 times 2 I know is 90. 45 times 3 is 135. 45 times 4, we get that 180. So to get from 180 to 45, we're going to divide by 4. And we get it 100 divided by 4. We get x is equal to 25. So it had a percent decrease of 25%. All right. So the GMC then. Okay, we got to figure out our change. So it started at 20,000 and it was down to 14,000, which is a change of 6,000. Okay, so our 6,000 change with an original of 20,000. And again, set it equal to x over 100. Okay, simplify. We got 6 over 20, which is equal to x over 100. Okay, I would go horizontal here. I can get from 20 to 100 by multiplying by 5. And we get 6 times 5, so x is equal to 30. So we had a 30% decrease in the price for the GMC. All right, finally, the Honda Pilot. We got 20,000 is the original price, and it's changing to 16,000. So the overall change is 4,000. And we said this was the Honda. Okay, so we had a change of $4,000, the original price of $20,000, and we set it again to x over 100. Simplifying with our zeros, we got 4 over 20 is equal to x over 100. Okay, and again, you can use your horizontal. Vertical works here as well. I like to multiply those, so I know 20 times 5 is 100. So 4 times 5, we get x is equal to 20, so which is a 20% change. So if the actual question is decide which vehicle has the greatest percent decrease, okay, greatest percent decrease would be the 30%. So the GMC has the greatest percent decrease. Okay. All right, so for the actual problem solving now, the longer a movie has been at a theater, the fewer people go to see it. That is a big reason why movies are not in theaters for very long. On Friday night, during the first week, the movie Attack of the Giant Cockroaches was playing. An average of 200 people attended. each viewing. By Friday night of the third week, the average decreased to 150 people per viewing. What is the percent decrease? Okay, so it started out at 200 and then it went to 150. So we got to find that change again by subtracting those two values to get 50. So the change was 50 and the original was 200. And again, we always set it equal to x over 100. Okay, so you can think of that as 5/20ths. Okay, so 20 times 5 again, times 5, which is saying 5 times 5, or 25. Okay, so there was a 25% decrease in attendance for that movie. All right, number 2, there hasn't been any rain or snow on the particular part of California for years. About 10 years ago, a lake in the region was 60 feet deep. Now it is only 48 feet deep. Okay, so that's how we're going to find our change. Started at 60, was at 48, and when we subtract that, we get 12. Okay, so there's our change, and it was at 60, so 12 over 60 equals x over 100. Okay, so then from there, okay, using our vertical or horizontal strategy, going from 60 to 12. Okay, sorry. Okay, we go from 60 to 12. What do we got to do? We got to divide. Okay, and we're going to divide by 5. So 100 divided by 5, you're going to get x is equal to 20, which is a 20% decrease. All right, number 3. Okay, Stanswood Forest is 80 square acres. There was a fire in July and 20 acres of the forest was burned. What percent of the forest was burned in the fire? Okay, this one's a little different because it actually gave us the decrease. Okay, it changed by 20. Okay, because there's still 60 acres, that changes 20. So we got 20 over 80 is equal to x over 100. Okay, you can simplify there, and I would use vertical in this case. 8 divided by 4 is 2, so 100 divided by 4, we get x is equal to 25. So a total percent decrease of 25%. All right, last one. Sanisa started the day with $20. She made it through most of the day without spending any money until she bought food at the store. By the time she got home, she had only $12. What is the percent decrease in the amount of money that she had? Okay, so she started with 20 and was down to $12. Okay, so that change, 20 minus 12, we get 8. So change over the original, she started with 20, so 8 over 20. Set that equal to x over 100. I would use my horizontal strategy here. 20 times 5 is 100. So 8 times 5, we get x is equal to 40. So that was a 40% decrease in the amount of money that she had. All right, so that was lesson 7. Make sure that you are completing your homework. Okay, lesson 7. Once we get down there, 4, 5, 7. Okay, so again, coming up with those algebraic equations given the input-output table. Okay, figuring out what operation you're doing between in an equation, solving a proportion, and then in your distributed practice. If you have questions, make sure you let me know. Otherwise, have a good day.